औज़ुबिल्लाहिमिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम अस्सलाम वालेकुम प्यारे बच्चों कि जन पतमिस क्लास मज पोर मेंडलस द हाइब्रिड क्रॉस तो अजुक टॉपिक डिविएशंस फ्रॉम मेंडलिज्म और डिविएशंस ऑफ मेंडलिज्म यानी डिविएशंस तम प्रोसेसेस those aspects of inheritance which do not follow Mendelism. Because Mendelism is generally when two parents with contrasting characters are crossed, only one gets expressed, only one character or one gene or one allele gets expressed in the F1 generation whereas other remains suppressed. The one which gets expressed, that is called dominant, and the other which remains suppressed, that is called recessive. In all the 7 pairs of traits which Mendel selected, he found this dominance and recessiveness, what we call as complete dominance. That process is a complete dominance. And yet, when two parents with contrasting characters crossed, only one parent gets expressed, only one character gets expressed in F1 generation, while as other remains suppressed. But when we study this inheritance in other organisms, other than pea plant and other characters, other than the characters traits which were selected by Mendel, many exceptions were found, many deviations were found. Those exceptions or those deviations we call it deviations from Mendelism or deviations of Mendelism. And the first deviation of Mendelism is that is incomplete dominance. Incomplete dominance. What is this incomplete dominance? I have already told you in complete dominance, the two alleles of an allelic pair, they are related as dominant and recessive. In incomplete dominance, the two alleles of an allelic pair, the two alleles या genes of an allelic pair present together in a heterozygote or F1 hybrid are not related as dominant and recessive, but both of them express partially to produce an F1 hybrid which is intermediate, that is mixture of the two, intermediate between the two, mixture of the two. Yet case is incomplete dominance you must say the alleles या the genes एक allelic pair यम हसा यकजा in a heterozygote या F1 hybrids में relate as dominant and recessive, and when they are present together in an F1 hybrid, चूँकि F1 hybrid one gamete from one parent, another gamete from another parent, one allele from one parent, another allele from another parent. आज अमराला चूँकि dominance में complete dominance में वुचा was dominant ब्याक was recessive, but here we see that they are not related as dominant and recessive. That is, neither of them is dominant nor recessive. Nach kaham was dominant, but both of them express partially. Donway has a partial expression hava. Complete expression hava ke partial expression hava to produce an F1 hybrid. It can be F1 hybrid which is intermediate between the two. You say intermediate, and you don't mixture. Don't mixture, and tell cases at which has complete dominance, that is no blending takes place. the two alleles, they do not mix. But here we see they mix, they blend. Mix blend F1 hybrid produce, that is mixture of the two. That is why this incomplete dominance is also called blending inheritance. This is also called as blending inheritance. Blending inheritance. Because F1 hybrid, that is produced by blending, by mixing the two. I think a partial expression. Mix, blend, third character produce, which is mixture of the two. This is incomplete dominance. Now, let me explain this incomplete dominance by taking an example. Now, this incomplete dominance, this can be explained by taking an example. Example, in a plant, Mirabilis jalapa. This incomplete dominance is shown by flower color in Mirabilis jalapa, that is called as 4-ocular plant. Example image, that is anti-rhinum species. Species anti-rhinum najas, anti-rhinum species. Dog flower. Dog flower. Common now. Botanical name, that is snapdragon. Snapdragon plant. That is arms of women. Dog flower. It also shows incomplete dominance. Now let me take one example. Because this is textbook question. When you say Mirabilis jalapas flower color, yukus dominance, yukus inheritance, explain that. Anti-rhinum species use inheritance, explain that. Snapdragon dog flowers use inheritance, explain that. Confusion, it is incomplete dominance. It is nothing more than that. It is only incomplete dominance. Now let me take the example of Mirabilis jalapa. You see Mirabilis jalapa, flower color. It shows incomplete dominance. Flower color. Flower color, which are Mirabilis jalapa, plants with two types of flower colors. A plant with red colored flowers, beaks with white colored flowers. Mirabilis jalapa plant, 4-ocular plant, red colored flowers, big white colored flowers. In them was cross, cross them. Generally says dominance red, not white. Dominant research. But here what we see, neither red is produced nor white is produced. But we get a third type of plant, that is called pink colored flowers. A plant with pink colored flowers. A plant with pink colored flowers. And all the F1 plants, they were pink colored, neither red nor white. This shows that neither red is dominant nor white is dominant. Neither red is recessive nor white is recessive. That is, the two alleles controlling red color and alleles controlling white color, and gene controlling red color, gene controlling white color, neither of them gets expressed. That is, the two alleles are not related as dominant recessive, but both of them express partially. It is which is a mixture of red and white, that is pink. Vozul to be safed pink. He allowed these pink colored flowers, they were allowed to self-pollinate. What he get? He get that in the this is F1 generation. F2 generation, he found that red, pink, and white are produced in the ratio of 1:2:1. And use Mendelism was F2 ratio, phenotypic ratio is which that was 3:1. And that was phenotypic ratio, F2 phenotypic ratio 3:1. Magar yet kya here it is 1:2:1. Use actually genotypic ratio. Here the phenotypic ratio is similar to genotypic ratio. And use phenotypic ratio which is similar to genotypic, magar Mendelism which has phenotypic ratio 3:1, magar genotypic ratio is 1:2:1. What we can see in incomplete domains, phenotypic ratio and genotypic ratio are quite similar. They are quite same. And if phenotypic of organism genotypically teacher, in incomplete domains, F2 phenotypic ratio is 1:1 and F2 genotypic ratio is also 1:2. Question in incomplete dominance, F2 phenotypic ratio is equal to that is basically 3:1, 1:2:1, 1:1:1, 1:1. You must remember that it is always phenotypic as well as genotypic ratio. It is 1:2:1. While as in case of Mendelism, it is 3:1 phenotypic ratio, 1:2:1 genotypic ratio. This incomplete domains, it follows Mendel's law of segregation both phenotypically as well as genotypically. Guys, Mendel's law of segregation is followed only genotypically, phenotypically in case of F2 generation. Here it is followed both genotypically as well as phenotypic. Antirrhinum species mans. Dragon flowers mans. And dog flowers mans. Snapdragons mans. This is all about the incomplete dominance. This is all for today. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.